resource and performance management. So we've moved ourselves through the build and install and configuration of our ESX environment, and then we've taken the virtual machines and from our physical standpoint and moved them into our virtual standpoint. Now we've got an up and functioning ESX environment that's really in steady state at this point. Now, one of the things that's the most important part about virtualization, just as a generic topic, is that virtualization really is all about performance management. And if you think about it, why do we do virtualization in the first place? We do it because when we look at our physical servers are, 3 to 5% utilized. And that's not very good when it comes to a sense of utility or utilization, right? If your servers are only 3 to 5% utilized, and that means they're 97 to 95% or 95 to 97% unutilized. And the reason why virtualization works is because they're not being used all the time. So when we think about virtualization, we're squishing together all of these servers into a single box. When we do that, we have to begin thinking about the concepts of performance management. And I always tell this story because it really resonates with me, because when I go and talk to different people about the things that they need to know as far as being a systems administrator, one of the things that I think we as Windows administrators have lost is really the knowledge set or the critical knowledge associated with performance management. And really it's happened that way because we haven't had to think about it for so very long. Moore's law comes through every 18 months or 24 months and doubles computing power. But we only have operating systems that change every 5 years or so. And because of that, we've kind of lost the skills of performance management. When you move your network into a virtualized environment, you're going to have to begin thinking about performance management every single day. And it's in this nugget that we're going to talk about some of those performance management skills. We're going to talk about how you can monitor resource use on the virtual machines in your environment. We're going to talk about how you can configure the storage of those performance metrics. One of the things that you gain whenever you move into a virtual center environment is the ability to store those performance metrics for your virtual machines over a long period of time, so you can do historical analysis. And then we'll also talk about configuring alerts and how you can configure alerts for your machines inside of your virtual infrastructure. Now, it's important to know that once you move your machines out of the physical world and into the virtual world, the old perfmon thing if you're using Windows, or performance monitor, or top if you're in Linux, or whatever your tool is inside of the virtual machine that is used to measure performance, doesn't really give you accurate measurements anymore. And so you can't really trust the old perfmon, our old friend perfmon, once you virtualized. You can't do that because of how virtual VMware actually time slices the resource use between different systems on a host. If there are multiple systems on the host, when that system is not being served by the host, when that virtual machine is not being served by the host, it essentially goes into a time wait mode. It kind of goes into a little mini pause that's a millisecond in size. And so because of those pauses, we're actually going to impact what those performance metrics are. However, if you look at performance from the standpoint of the ESX server, the ESX server can actually adjust for those, compensate, if you will, for those time wait situations. And we can see what the performance is of any of our virtual machines over a period of time. You'll see here that over the last hour or so that we've had a spike in CPU usage for Nugget 2 in percent, and then also in terms of total megahertz for that particular system. Here, right about 1 o'clock or so, and again right now about 1:20 or so. And as we look and we kind of click inside the screen here, we can see where those situations are occurring, and we can get more information about those situations on our systems. If we're interested in seeing more than just the standard chart options, we can change those by clicking on Change Start Options. And this gives us the option to customize that performance chart. Obviously, having real-time information is useful for understanding what's going on in the system right now, but that's not useful if I'm trying to get a long-term historical view of what's been going on in my system. If I want to see, for example, what's gone on over the past day in terms of usage of my system, I can click on Past Day and get more information about CPU usage and megahertz or total usage. Let's just do percent here so we can just see what the percentage is, and click OK. And that will rewrite the graph. So we'll see, starting at about 11 a.m. this morning, then we had a nice spike in usage, and then it's sort of been in steady state ever since over the past day. And so as our systems begin running throughout their entire process, we can look at their performance here inside of the performance graph. The same thing happens here if we click on each individual host. If we click on the individual host and click the performance tab here, we'll get a view of the system performance across a period of time. So whereas before we saw the performance of the individual virtual machine, by clicking here, we can now see that individual host and how the performance is going on that individual host. You'll see here that same spike that occurred here at 1 a.m. because we had one virtual machine that was having a spike condition around that time, and that one virtual machine actually impacted the performance of the entire machine. What I tell people when they put together their virtual infrastructures is to go buy one of those big jumbotrons and put that jumbotron up in their data center or even in their office, and then keep this graph going so you can see what the performance is, and you can very quickly see if you're having performance issues on your servers. And plus, having those big, flat screen TVs in your office makes you kind of look like you have a little mini network operations center in your office anyway. It's kind of fun to watch. And so this gives you an ability to really get a good understanding about what's going on in your system. What you'll hear from your users, because you've got all of your virtual machines wrapped up into individual hosts, is you'll hear from your users, well, certain things are slow today. And the only way that you can figure out why something is slower today than it was yesterday is by monitoring and managing that performance. One of the other things you'll notice here, there are three little buttons up here in the upper right-hand corner of the screen, and they're kind of hard to see because we've got our screen squished down to 800 by 600, but we have the ability to refresh the chart data here. This is actually two arrows pointing at each other to refresh the chart data. We have the ability to detach the existing performance screen so we can see it as a separate screen, and I'm actually dragging this over from my other monitor right now. You can have this as a separate screen so we can see this separated from our usual virtual infrastructure client if we want. And then also we have this little icon here for saving data. If we want to actually save our performance graph, we can do so by clicking this item and actually save it as an Excel spreadsheet, for example. You'll see here performance.xls. Real-time information. Do we want a line graph, a stacked graph? Do we want to show CPU information? What are we interested in showing as part of our performance measurements? You need to monitor not only CPU, but memory usage. You need to monitor for disk usage if you're having disk spiking, if you're thrashing your disk, if you're using too much of your network availability. You need to monitor for these. And knowing what exactly those thresholds are is something that you will begin developing over time. One of the things you'll also probably have noticed over the last series of nuggets are how the icons for each of our virtual machines, and then also the icons for the servers servicing those virtual machines, change over time. When we look at the icons that are associated with each of these virtual machines, these are giving us warnings and also notifications about what's going on the virtual machines on our system. You'll see here we have a yellow dot and a green dot associated with the status for these two systems. You'll see here the status is set to a yellow dot for Nugget 1 and a green dot for Nugget 2. Now, what do these mean? These notifications are telling us that the performance of our machine are going above certain notified specs. And so what we're seeing here is that certain alarms are being triggered based on pre-configured notification parameters inside of our system. So that we know whenever this green dot turns to yellow or turns back to green, that the RAM usage or the CPU usage of that system is going beyond some pre-configured specification. So where do we actually do those pre-configured specifications? That's here under the Alarms tab. If I scroll over here to Alarms, you'll notice that we have the option to see some of the triggered alarms that are available, and also we can choose what the definitions are for those alarms. Now, as you'll notice that we went back to green here while we were talking, and by moving back to green, that performance went back down underneath that specification. What was that specification is defined here inside of our definitions. So we see host connection state is a default alarm to monitor host connection state. Are we actually being able to see this system? Are we able to see CPU? Is our CPU going up too high, or is our memory usage going up too high? A lot of times you'll see these alarm whenever you have systems that are powering on, because the power on process, as we've said before, is one of the hardest things that you can do to a virtual machine in terms of resource use. Let's take a look at CPU use here, and we click on data centers so we can see at the data center level, what is the definition that we've created for this CPU usage. If I right click on CPU usage, I can click edit settings to see more information about the alarm settings that we've created. This is a default alarm that comes pre-packaged with the installation of the operating system. And you'll see here we have host CPU usage, and the alarm type is there to monitor a host as opposed to monitoring a virtual machine. And we have a trigger priority which says, okay, are we going to trigger a red priority or a green priority? And red priorities will trigger first. We have a trigger here that says, okay, if host CPU usage is above 75%, then give us that yellow dot. If we go above 90%, then give us the red dot. And if we find that this really isn't working for us anymore, we can always change these numbers by clicking the drop-down list or entering in information here. If we're tired of seeing yellow dots at 75, and in fact we want to make that 85, we can change that right here, and this will globally impact all of the alarm settings associated with this alarm across our infrastructure because we're doing it at the data center level. We can choose to report on this alarm settings as well. This allows us to help kind of prevent ourselves from being overpaged, if you will. The tolerance says once an alarm is triggered, it will not trigger again unless it leaves this tolerance range. That's what percentage above or below do you have for that tolerance. And then once again, once an alarm is triggered, do not report a change again until 300 minutes have passed. So you don't end up with the bounce situation where you're constantly bouncing above and below a particular alarm threshold when you're right at that threshold. Lastly, we have the ability to choose a certain action that may occur when something triggers. So if we go from green to yellow or yellow to red or back down again from red to yellow or yellow to green, we can trigger an action that says, okay, go ahead and send a notification email to someone or send a notification trap to an SNMP service or even run a script if we want to complete an action, a remediation action to stop that from occurring. And a lot of times one of the best things you can do is send a notification email to someone to say, okay, go ahead and just notify me that I'm having a problem, that my system has gone above its specification, and I need to be aware of that alarm actually triggering. The value we want to put in here is our email address. Maybe we'll put it in here, bob@bob.com or whatever our email address is, cbtnuggets@cbtnuggets.com, for example. So this allows us to send a notification email when a particular trigger occurs. In this case, we'll say, okay, once we go from yellow to red, go ahead and trigger this email to occur. I click OK here. And it brings me back to my Alarms tab screen again, so I can look at alarm definitions. Now, we just entered in email information about wanting to send an email out to us whenever we get a notification, but where do we actually identify where our SMTP server is? That's up here under Administration. If we click Administration and Virtual Center Management Server Configuration, that'll bring up that screen that we talked about before in one of our earlier nuggets about how to set up for mail services. If we have a mail server here, if it's cbtnuggets.com and our sender account is cbtnuggets@cbtnuggets.com, then we can bounce mail off of this SMTP server. If we're using SNMP, if we're sending traps out, obviously we're going to have to put in a receiver URL and or a community string in here for us to be able to send traps to that SNMP receiver. We can do multiple receivers in here, obviously, because you have receiver 2, receiver 3, and receiver 4. That allows us to send multiple traps out to multiple locations if we have different receivers for load balancing purposes or failover purposes, or even different receivers that have different consumers of this information. So we want to make sure this is we can make ourselves aware of when there are performance problems inside of our virtual infrastructure. We do that by configuring these alarms. If we want to create new alarms, we can right-click down here and choose to create a new alarm. And one thing I want to show you here is that by creating a new alarm, that's our new alarm, we can choose quite a bit of different triggers for what we want to choose for our new alarm. If I click Add in here, obviously I'm going to choose a default for host CPU usage, but there are also memory usage, network usage, disk usage, and then the state of the host as well. If the state of the host is equal to connected, disconnected, or not responding, we can choose how we want to notify ourselves when we have a system that just plumb is not communicating whatsoever. So we want to be aware whenever we have up-down notification. This is the concept of host state. We want to be aware when our memory use starts to balloon, or when our processor use, or even when we're thrashing our disk or we're using too much of our network. And by doing that, then we can do remediation actions through here by either notifying ourselves or by setting up some sort of script to run that will help us solve the problem in a more automated sense. Now, if you're the kind of person that would prefer to see something in a command line sense as opposed to seeing it inside of the GUI, there are a couple of tools that you can use inside of the service console that will help you also with understanding more about the performance on your system. The first of which is your typical Linux top command. If you type in top once you log into the service console, you'll see here not only what is going on in the system, but how the performance of that system is being consumed on a stacked graph here. Starting at the very top, you'll see the process that is consuming the most CPU CPU, and it works its way all the way down. And this gets updated every second or so. You'll see here, we'll see what the uptime is, how many users and what our load averages is, how many processes are currently being run on this system, and of those, how many are sleeping and how many are running, and what the CPU states are for the various processes, and how much memory is being used. We have a certain number of average and used and free memory available in our system. We also have an understanding of what our swap space is. Right now, we're not using any of our swap space, which is potentially a good thing in an ESX environment. You'll see here what our percent memory use is and our percent CPU use is for the various processes that are running inside of our Linux server. So this takes away some of that layers of abstraction that you get from the virtual infrastructure client, but it doesn't give you good information about the individual systems that are running, the individual virtual machines that are running on your server. If I go ahead and hit the Q key, that'll actually log us out of the top command. The other command that you may be interested in knowing about is called ESXtop. And what ESXtop does is it adds a little bit of a layer of abstraction to the top command to give us some understanding about the VMware-centric processes and what those VMware-centric processes are doing on our system. So very similar to top, we know, well, essentially how long has it been up and how many worlds do we have, what's our load average for CPU. We can go down here and look at process IDs and GIDs and what the names of those processes are and get an understanding for how the utilization is for those processes. You'll see here that Nugget 1 currently is using 62% and Nugget 2 is using 66%, and it's jumping around in here. What the runtime, what the wait time percentage is, what the overlap, exactly all of the performance information about our system. So this helps us get an understanding from a command line sense of what's going on in our systems in terms of performance. So what have we talked about today in this nugget? We've talked about resource and performance management, and we've talked about how virtualization really is all about performance management. And if you think you're going to be able to just squish a bunch of machines into your ESX environment and just watch them play happily with each other, you're sadly mistaken. Because once you actually move into that virtualization environment, it's going to be up to you to kind of keep an eye on what the performance is of all the systems on your network. Because they're playing together in that central location, you're going to have to make sure that they play well together and play the role of systems babysitter as you watch your performance management graphs. Again, maybe a good idea is to put together a Jumbotron or a large television flat screen panel and put it in your office so that you have the ability to see from a one snapshot view what the performance is of the systems on your network. And you can do that with the ESX console. We talked about how to monitor for resource use and also how to configure some performance metrics and metric storage, as well as also configuring those alerts to notify you either by running a script or setting an SNMP trap, or even emailing you directly whenever you go above certain alert thresholds. All of this information is going to float into the next nugget where we talk about clusters and resource pools and DRS and HA. Because once you understand what the basics are of performance management, then we're going to take some of that knowledge and really work it into how we can load balance our systems so that we're using the performance the best way possible. We'll be doing that in the next nugget when we talk about clusters and how we can do distributed resource scheduling within those clusters. I hope this has been informative for you, and I'd like to thank you for viewing.